Well, my name is Michael Omari, and I am the owner and inventor of the Bio Eco Healer filters, Bio Storm Water / Industrial Water Pollution Elimination Systems. And we are here today. We're going to be doing a demonstration with a filter medium and show you the efficiency using in removing pollution from two controls. This control that I'm holding in my hand, you can see it contains about perhaps as much as 10% of oil and heavy minerals that are associated with diesel trucks, concrete trucks. We actually scraped the concrete trucks exhaust to get some metals that are that go into the air. And I had them put in, also include in this oil from the concrete trucks, used oil which contains a lot of pollution and minerals that is a problem for the environment in our inner cities and all that. We're gonna mix it all together. This, I have tests that similar with this, and it contains quite a bit of minerals. I think that's where we got those minerals on Title 22 from, these kind of control samples for our testing that went to the lab. So that's one. This one here is an effluent of concrete washout. That's when concrete trucks finish their end of the day and they wash their drums, concrete drums. They wash the cement, and that cement creates high. It has high pH. The pH level on this is about. We're gonna measure it pretty soon. Is about 13.5 or higher. That's about this liquid here is, I would say, 55–60% OH negative. It looks like water, but it's not water. It's highly, the one drop, if it's splashed on the eye with this one, it will blind the eye, from what our scientists telling us. And to give you a comparison, the bleach that we use for the clothes and the drain cloggers, uncloggers and openers, they have a pH level of about 11. This one contains 13.5 or more. That means it's about 5,000 times stronger than the pH that we do, because with every level you increase times 10 by the power of 10.
Right.
So between level, we're going to reduce this pH level from 13.5 today with this just roughly about 10 inches of filter material. We're going to be able to neutralize it totally to perhaps 7–7.5. We'll see what the test is going to show us. Be neutralized. And the difference between 7.5 or 6.5, let's say 6.5 and 13.5 is 7 points. That means 7 zeros, starting from the 10. 7 zeros that means we're going to be cleaning it, really neutralizing it. But if it was to say that we're measuring 6.5, we're measuring the percentage of pH from the 13.5, it would be 1 in 10 million that would be measurable out of after it went out of the filter.
Cool.
And the rest of it would be neutralized. I'm going to start by taking some of this water.
Can I do something to help you, Michael? Do you have another set of gloves?
No, I don't have any, but I'll handle this. Thank you. Just enough to get the pH instrument here. This will measure the pH and the electrical conductivity in it. And we're going to see now it's at 7.7 and start jump 11.12.5, 13. Wow. It's going to keep on jumping. 13.5, 13.6, 6.7, 70, 13.72, Can't get worse than that. 13.76, 78. There it is, 13.82. 13.83. This is almost a pure OH, negative. A negatively charged ion with a negatively charged electron that rips life out of vegetation, out of fish, out of water, and even our skin, and even that damages the bone permanently. That's almost 14, 13.88.
Might as well round it up. Good times.
Okay, now we got, I'm gonna just pour this through the filter. Let me just show you the filter material here. So it's no magic about it. It's a natural mix of, very smart mix of different kind of and matured and treated vegetable plants. 3 parts.
Now, are you guys making this, or are you just sort of scraping up from nature and just sort of drying it and stuff?
It's a special blend, and it needs treatments and other things. And for each little thing to do, it's a specific job. It's a particular job. I'm gonna do this now, so it will drain.
I can hold it.
Maybe, no, we don't want to hold it because I want it to drip for a while. Maybe I just can set it at the corner here. I want it to drain. I want it to drain inside, not on the thing. Alright, so I'm gonna get this in and we can continue with this, and then, but I want to wash this first from the high pH so we can measure and wash the, oh no, I'm sorry. We want to wash this. By the way, this tap water is about 8.8, but it'll take it a while to drop down because any little radiation from the pH affects it. It's so sensitive. Rinse it one more time. Oh, let's do this.
It doesn't work.
It's going down to 10 something, 10.9. It takes the time to drop. But meanwhile, while it's rinsing and dropping down in here, I rinse my hands. My gloves on one more time. We take safety seriously, as that's being a licensed contractor. That's what our primary job is, or our trade called building and safety. It's all about safety. So this little sheet on top is, we use it for to equalize the inflow. Distributed evenly, so it won't just go pour in one little place. You can see that because it's a vegetable material and it's been kind of fermenting for a while. I used this for a test, and the last test we had on it about 10 days ago. It has that tannish color, which is the tanning from the vegetable natural material. The US EPA environmental code has no limitations on tannings because they are not part of the natural cycle of the ecosystem. They are beneficial to the ecosystem. In fact, they are used, vegetation tannings are used to spray pesticides and those preservers on vegetables and fruits. We have enough in there that's going in that we can test, see what we're going up with. Rinse it with the tested material for efficiency. And take it a while to stop. I think it's still contaminated somewhat. We're measuring 9.5. I'm going to do a little rinsing here. So it keeps on. It's going to be dropping down gradually until it settles at the right score.
The probe we're talking about. The water is what the water is, but you're talking about the
this is the
response of the probe.
The response of the probe is slow.
Right.
You guys tested a carbon filter
Last year.
last year, and what were the outcomes of that?
It worked pretty well. We were looking at metals.
So
greases.
it's down to 9.17. It takes a while. We had an extremely high pH, and the flow that I did it in was a little bit of a quick flow for this is a half a square foot filter medium. It's going down to 9.10. The code requires it to be between 6 and 9. It's gonna keep going down. It will. This one is taking its time. It's on 9.05.
We start at 13.88, correct?
We start at
almost 14.
13.88. Yeah. And what it is also it's that always after you measure it from measuring 13.8, no matter what you have, you can't clean it enough to get rid of all the higher pH effect on it. So we're now below the 8.98. It will keep going down. Now we just set this aside while we're doing the next experiment. And 8.95. I'm going to remove this. Now we have this nasty concentration of oil and grease. This is probably what when they pump oil you have it that much, grease in it. Of course this is not a representative of what the kind of pollution, amount of pollution we have in here.
So this would be even better.
This is the one where this is the longest.
Highly effective in stripping the water, not only of the floating sediments and oil, but also of the diluted sediment that gives it the nasty smell.
And you can see already, so this is dark, and that's nice and clear, at least, for a particular perspective.
And we have only here about 10 inches of filter medium. If we had 12 inches where we like for the pH, we like it to be 16 inches.
Okay.
So that's why it didn't, otherwise it would drop it down to 6.5. But with this. But because it went in through about 10 inches. Now we're gonna get some sample of this. See, it's and the tanning is getting less and less and less until eventually you could hardly notice it after several gallons have gone through it. But you can see if against the sun you have no
chunks.
No, not only no chunks, but you don't even have to see that rainbow kind of a thing above from that you see from oil.
The sheen, yeah.
That's on a similar test that we did for Rincon Engineering. They measured 17 parts per million of oil in the effluent. And with this one here, it would contain perhaps 100,000 parts per million, I would imagine, with this kind of concentration. So you can smell, no oil, nothing. It's just the natural concentration.
That's good. See, someone is using their actual appropriate chemistry way to smell it. That's good. I'm glad somebody took quantitative methods.
I've had some. So
So now it's all that oil is captured in the medium, and in a few days it will go back to dry and clean, and that's because our microbials will clean it up, will consume it. They'll consume it.
This is great, man. This is super cool.
As simple as that. Gravity operated, no pumping, nothing. And now
non-toxic. So if something
so
were to blow up or whatever, there's can't hurt anybody.
Can't hurt anybody. We had tested the effluents and we tested the bacteria with the professor of public health department in Northridge University. There are no pathogens in the microbials. No known pathogens. So we're safe in there to release it into the environment. We're not releasing anything. In fact, if any of this is going to be released, from my theory, that it's going to go dormant, because when the microbials run out of things, they kind of go curl up together in a yeast kind of form, and then if they dry up and nothing else, they go and fly in the air, and they find pollution, and then they grow wherever polluted. So if they release into a stream, they're going to go dormant along a rock or something until there's food for them, and they attack that food, clean it up, and go back to huddle together, and that's how it's going to work. So
cool.
It's the answer.
Awesome. So there we go. So there was...
You don't see any film whatsoever of that top little thing on the oil. It's all cleaned up.
So nasty stuff. Yeah. High pH stuff seems to do well.
Well, you read my our lab test results that we have. That one sheet of the lab. Those are by American Science Laboratories, which are registered and qualified with US EPA regulation, and they do their according to that. So all of these metals that we have in there, the Title 22 metals that on that sheet reported, we tested them right now. Have you tested the influent and the effluent out? You will come up pretty much the same metals, because those tests that we did there, that we sent to the lab, they had the same control. Is the pollution from concrete washout water, and from trucks and cars and oil and grease and that stuff.
Yeah, that's great.
That
concludes
awesome. Our little experiment.
And then if this was in actually installed, it's just going to stay there, and then when the rain stops, it's going to dry out, and it's going to be ready for the next water input.
Yeah, just like you saw it when we first came. I was. It's all now. It's all kind of up. It's all full of oil and grease. It's just gonna dry up and go back after a few days, maybe a week or 2 weeks. For sure, you're not gonna see any of this whatsoever. It's all gonna be cleaned up and consumed. That's the magic of this. This is we called it ecology healer, biomicrobial ecology healer.
The ecology healer.
Ecology healer. That's the name of the filter, and that's what it's doing. It's living to its name and expectation. We were totally surprised, as if you know something about chemistry and electrical. This system does its lowering of the pH, neutralizing of the pH through chemical electricity. The atoms of that, in other words, it supplies atoms from the medium to balance out the OH negative into OH2, H2O, so it's a miracle, environmental miracle, and I'm happy that I had part in discovering this. So let's see what the pH is going now. It's still high at 8.72, and I say it's not high. This is what higher. It's cleaner in pH than
13, 14, yeah.
Well, then even the tap water. Where's the tap water? The tap water is about, right now they've been keeping it to about this level, to pushing it to 8.98. Just a dash below the 9, the maximum limit. And that's because our reservoirs are going so low, I suppose, or whatever they're doing to our water. But this is good enough water to use domestically and to release into the environment.
Cool.
From 13.38. And with our filter that we're going to install here, we're going to do at least 14 inches of medium, maybe 16 inches of medium. So none of this will escape. It would be
contained,
totally neutralized.
Cool.
Yeah. So 8.76.
All right. The Eco Healer.
Eco Healer. It's the Eco Healer.
Cool.
Also, Jason asked me to test it if it also neutralizes acidity, high acidity in the water. And yes, it did. The same filter, this is the same filter that removed the pH. Also, we tested it with 3.5 acidity level.
So it'll take it both ways. It'll take it all to neutral.
5.7. One pass.
Cool.
Really cool.